Assalamu alaikum, dear students. This is Shamshad Ali, Department of Technology. Your course is Foundation Engineering. Its code is CD314 for the program of BSc Civil Engineering Technology. Today we are going to learn about the foundation and its types. Okay, so today is week first and also our lecture is lecture first. You can access this lecture at portal.sood.edu.pk. So let's begin. Okay. First of all, we will learn about the objectives of the course. The first objective of this course is to develop an ability of applying the layout and alignment parameters to the highway design and its construction. The second objective of this course is to develop an understanding of the design of rigid and as well as flexible pyramids. Last one, to understand the design of foundation. Definitely the course concerned about the foundation, so you will learn about the design of foundation. Geotechnical design as well as the structural design of the foundation. In the next lecture, inshallah, we will learn about the design of foundation, both the geotechnical design and structural design. Okay, so now what is meant by the foundation? First of all, we will learn about the foundation. That what is foundation? Okay, foundation, the structure that transmits the load of the building to the soil or to the adjacent soil. Basically, foundation is a structure that transmits the load of the building to the soil. As we are seeing in this figure, that the load is transferred to the soil through the foundation. Basically, foundation plays an important role in the transmitting of the loads of the superstructure to the underlying soil. To safely transmit these loads, foundation has to be designed. Okay, the soil layer that has the sufficient load bearing capacity in relation to the chosen foundation type. As shown in this figure, that loads from the top portion like gravity loads from this layer basically transfer to the beams. Here we have beams in our direction. And then to the columns. These loads from this layer transfer to the beam and then to the columns. And onward to the footing. This is basically the foundation of the footing. The upward forces are basically the bearing capacity of the soil, mean the upward forces or the upward resistance shown by the beneath soil. The primary design concern are settlement, which is maybe total settlement or differential settlement, and load bearing capacity. To design foundation, two design parameters should be kept in mind. The one is settlement of foundation, and the second one is bearing capacity of the soil. Further, we will learn about the total settlement and differential settlement. This picture is about the foundation. This is the foundation of a tower, some kind of windmill. Okay, footing. Footings are structural elements which transfer loads to the soil from columns, walls, lateral loads from earth retaining structure. In case of earth retaining structure, lateral loads. In order to transfer these loads properly to the soil, footings must be designed to prevent excessive settlement, minimize differential settlement, and provide adequate safety against overturning and sliding in the case of earth retaining structure. This is basically the proper definition of the footing. Footing are basically the structural element that transfer loads to the side of the superstructure. Okay. Bearing capacity of the soil. In geotechnical engineering, bearing capacity is the capacity of soil to support the loads applied to the ground. Basically, the loads are the loads of the superstructure in case of buildings, lateral forces in the case of the earth retaining structures, etc. Okay. Ultimate bearing capacity. What is meant by the ultimate bearing capacity? It is the theoretical maximum pressure which can be supported without failure, and the side which support maximum pressure, theoretical maximum pressure without failure. So that bearing capacity of that particular side is called the ultimate bearing capacity. Now, allowable bearing capacity. Allowable bearing capacity is the ultimate bearing capacity divided by a factor of safety. In the next slide, we will discuss different factors of safety from different categories of the structure. So, allowable bearing capacity is the ultimate bearing capacity, meaning the theoretical maximum pressure, which will be divided by a factor of safety. So, the resultant bearing capacity is called the allowable bearing capacity. As in the next slide, we have the different bearing capacity of the different structure. First one is the category, okay, and this is the typical structures. This is the characteristics of the category. Characteristic of the particular category. Design factor of safety. Now we have both the columns. The first one is thorough and complete soil exploration. If your soil has been explored thoroughly or completely, then factor of safety is different. And if your soil has been explored limited, or for the limited soil exploration, your bearing capacity will be different. So, category A. Railway bridges, warehouses, blast furnaces, hydraulic retaining walls, silos. For these type of structures, maximum design load likely to occur often consequences of failure or disasters. Okay, this is basically the characteristic of particular category. So, if your soil has been explored completely, all type of exploration has been done, so your factor of safety will be 3.0, or we can say like 3. If your soil is explored limited, then your factor of safety will be 4. Further, on the right side of the table, category B, highway bridges, light industrial and public buildings. Okay, characteristic of the category: maximum design loads may occur occasionally. Consequence of failure are serious. Then your factor of safety, if your soil has been explored thoroughly or completely, then your bearing capacity, then your factor of safety for the bearing capacity will be 2.5. And if your soil has been explored limited, limited soil exploration, your factor of safety will be 3.5. Now comes to the category C. Okay, apartment and office buildings. This is basically the type of the structures. Maximum design load unlikely to occur. The design load of the superstructure unlikely to occur. Then, if your soil has been explored completely, your factor of safety will be 2. And if limited soil exploration is there, so 3.0, or we can say 3, will be your factor of safety. Okay. Now, settlement. As we discussed in the previous slide, that the design parameter, design concern for foundation engineering will be settlement and the bearing capacity of the soil. So, settlement. Soils deform under the load of foundation structures. The beneath side of the foundation deform under that load of the foundation, and as well as the load come from the superstructure. The total vertical displacement, vertically displacement will be vertical in case of the buildings. The total vertical displacement that occurs at foundation level is termed as settlement. If your structure moves vertically from its original position, as shown in the figure, so that will known as the settlement. Now, total settlement is the degree of downward movement. Okay, differential settlement is From the name, it is clear that differential settlement is non-uniform settlement. It is the difference of settlement between several locations of the structure. Now comes to the figure. These are the types of the settlement. If you can see, this is the original building, but previously its original position is the dotted line. Okay? So this structure moved downward. So the settlement is uniform. As we can see that the height here is the same as on the left side. This is basically the uniform settlement, or we can say the total settlement. In this structure, this is basically the tipping settlement, often without cracks. There will be no cracks here, often without cracks. Cracks may be occur, or there will be no cracks in this situation. The original position of the structure is the dotted line, but it moved slightly to the right side. So this portion settled a lot as compared to this. So this is called the tipping settlement. Okay. And in the right side, this settlement is termed as differential settlement. Differential settlement will always have cracks. If you can see, this is the crack on the right side. So the building is stable on this side, but on the right side it moved downward. So means settlement has occurred. So this is basically the differential settlement. Okay. Now we come to the types of foundation. Foundation is mainly two types. One is shallow foundation, is shown in the tabular form, or someone call it hierarchy. So this is basically foundation systems. This is the shallow foundation, and another type of foundation is the deep foundation. Shallow foundation is further categorized. The first one is isolated, or we can say split footing. The next one is the wall footing. The third one is combined footing. The fourth one is cantilever or straight footings. And the fifth one is rub or mid foundation. Okay? Deep foundation. Deep foundation is further categorized like pile foundation, pier or caisson foundation. Okay. Further, we will discuss these in detail, the subcategories of the shallow foundation and the subcategories of the deep foundation. Okay. So, first we will explain the shallow foundation. So first we will explain the shallow foundation. These are usually located no more than 6 feet below the lowest finished floor. If the depth of the foundation is 6 feet, sorry, 6 feet, then it will term as the shallow foundation. A shallow foundation system generally used when? Where we will use the shallow foundation? So the soil close to the ground surface has sufficient bearing capacity. Okay. So if the soil near the ground has sufficient bearing capacity, mean if it resists the load of the superstructure without the failure, which is the settlement, mainly the settlement. So shallow foundation will be selected for a particular structure. The second one is underlying weaker strata do not result in unnecessary settlement. If the weaker strata do not result in unnecessary settlement, the shallow foundation are commonly used most economical foundation system. Okay, it is clear that where you use the shallow foundation, so it will be an economical. Okay, so now we come to the deep foundation. Deep foundation, the shallow foundation may not be economical or even not possible in the soil bearing capacity near the surface is too low. Where the bearing capacity of the soil is too low, so you may go to the deep foundation system. In those cases, deep foundation are used to transfer loads to a stronger layer, which may be located at a significant depth below the ground surface. The load is transferred through skin friction in EN bearing. Now come to the figure, we will explain how it works. In the left picture, we can see that there is EN bearing. This is basically the EN bearing. Why it is here? Because EN bearing to be fired due to the presence of the hard side of the bedrock. Okay, there is a hard rock at a sufficient depth, so it has the EN bearing. EN bearing means that the soil can resist the load, or the hard rock can resist the load of the superstructure, which comes from this direction. Skin friction is in upward direction. This is basically the skin friction. Skin friction from the pipe. And load of the structure into the downward direction. This is basically the one force is in upward direction, the other force is downward. So it basically in a sense it balances each other. So this is basically deep foundation, it may term is the pile foundation, which we will explain later in the next lecture. On the right side, the picture, the situation is quite different. In this picture, the situation is quite different. There is no EN bearing. I mean, here the EN bearing is negligible because of the absence of the hard rock. There is no hard rock available, or the hard strata, or the high bearing capacities. So here is no EN bearing. All the load which comes from the superstructure can be resisted by only the skin friction of the fire. Okay, so that is it for today. In next class, inshallah, we will learn about the choice or selection of foundation. So thank you so much for listening. If you have any question, please give it on your Zoom portal. Thank you.